Hello, and welcome to another conversation with myself, Mark Vernon, and Rupert Sheldrake. Hi there, Rupert.
Hello, Mark.
I wanted to talk about gravity today because we were at a meeting a couple of weeks back, and you made some very intriguing comments about gravity, which, to be honest, even as someone who did a physics degree at one point, hadn't occurred to me. And just to plunge straight in, one of the remarks you made was about the speed of gravity, that gravity actually travels across the cosmos. And I hadn't thought about that before because I had taken the Einsteinian sense of gravity that it's a feature of space-time. And so mass warps space-time, a bit like indentations in a great plastic sheet. And that's what causes objects to move around each other and so on as they follow their path in space-time. But you were raising another aspect of this, which is the fact that not only does gravity travel, but it travels much faster than the speed of light, in fact. So where does that come from?
Somebody wrote to me about gravity a few weeks ago, and they gave me a reference to a paper by Tom van Flandern, which was published in Physics Letters in 1998, and it's called The Speed of Gravity. And Van Flandern's a physicist, and it's a completely fascinating paper. We could put a link to it actually in the notes here because it's not terribly technical. I mean, anyone could read it. And what Van Flandern shows is that gravity is actually, in practice, treated as if it's instantaneous in all calculations of celestial mechanics. You know, if you're calculating the orbits of the planets around the sun, or if you're calculating a moonshot or anything like that, it's treated as instantaneous in practice. In theory, according to Einstein, no causal influence can go faster than the speed of light. But gravity is a causal influence. It causes orbits and things. And he points out that if gravity traveled at the speed of light, since it takes 8 minutes for light to get from the sun to us, if you actually assumed that the gravity was traveling at the same speed, the sun, you'd have to put the sun as it moves sort of 8 minutes further back. Its position would be different. And if you do that, all calculations go wrong, all orbits fall into chaos, etc. The only way you get the right sums is by treating it as instantaneous. And physicists don't think about it much. They just assume it's a kind of calculating convenience. And if asked what the speed is, they say, well, it must be the speed of light. As Van Flandern points out, that simply can't be the case. And yet you can't really assume it's instantaneous because that would violate causality so he's worked out from astronomical observations, from things on eclipses, from the movements of black holes around each other, from binary star systems. There's a lot of data that's relevant, but he's worked out that the speed of gravity must be vastly greater than the speed of light. Pierre Laplace, at the beginning of the 19th century, the great physicist who did so much to found 19th century mechanistic physics, assumed that gravity must travel at least 100,000 times the speed of light. Van Flandern calculates it as 20 billion times the speed of light. And this is very, very remarkable. Our galaxy is about 100,000 light years across, which means it takes 100,000 years for a photon of light to go from one side of the galaxy to the other. A gravitational influence would travel across the entire galaxy in less than 1 second. So it's completely different order. And Van Flandern then shows that in order to have an influence that moves out, that it's not a static thing, the gravitational field, an influence moving out from something that changes position, then its influence of that changed position should radiate out from it, is like some kind of emanation streaming out at this enormously high speed across the whole universe. And everything in the universe with mass is streaming out these gravitational influences. So the entire universe is filled with these influences. Now, that to me is an absolutely fascinating picture, and the fact that physicists have to treat it as instantaneous is their approximation to this immense speed of 20 billion times the speed of light.
So is this related to speculations about developing a warp drive? If we wanted to get into interstellar travel, maybe even in interplanetary travel, it would be quite handy, but certainly interstellar travel, that could be done within a human lifetime, maybe, much, much shorter than that. The idea is that you would have to develop a means of propulsion which wasn't just about accelerating as close as possible to the speed of light, which would still take quite a long time to travel between stars, but instead would warp space-time itself around the craft. And then the idea would be that the craft would travel at these phenomenally much faster speeds. So might even be able to traverse the Milky Way in a second. It's related to the same notion, is it?
Well, he doesn't discuss space warps or science fiction-y type things in his paper. He just sticks to regular astronomy and cosmology. But I think it made me, what it did was sort of made me go back to thinking about Newton's approach, because Newtonian mechanics is taken as the very hallmark of mechanistic science. It's like the kind of gold standard of mechanistic science. And yet Newtonian physics, the centerpiece of it all is Newton's theory of gravity, which is his greatest discovery, really. And Newton thought that gravity was instantaneous. And he also thought that what it showed was that everything in the universe was related to everything else. And Newtonian mechanics is often dismissed as being sort of crudely reductionistic and stuff, but actually it's a completely holistic vision. What Newton is saying is that every particle of matter in the universe attracts every other particle of matter in the universe. Everything is interrelated, instantaneously interrelated, according to Newton. And he couldn't explain gravitational force itself. He didn't think that gravitational force could come from matter, because he didn't think matter, brute matter, would have a capacity to act over the whole universe. He thought of it as localized. So in order to explain it, he didn't know how to explain it. He made that famous statement, hypotheses non fingo, I feign no hypotheses, saying he wasn't pretending to explain it, he just had a mathematical law that enabled you to calculate, but it didn't tell you what it was. And later in his life, he speculated that actually the cause of gravity was the direct cause of the will of God, and that absolute space, everything was in absolute space for Newton. Absolute space was the sense organ of God. That absolute space meant that God knew where everything was, and could feel everything that happened, because space was God's sense organ and everything's in space. So that was Newton's way of thinking of it. But he had a rival in everything throughout his life, in the form of Leibniz, the German philosopher.
Mm-hmm.
Also invented the differential calculus, and Newton and Leibniz had endless arguments about almost everything. And Leibniz's view was that every particle of matter, every unit of organization, or monad, as he called it, consciously reflects the entire universe from its own point of view. So Leibniz put consciousness in all matter, and said that in Newton's case, every bit of matter was related to every other bit of matter in an unconscious way from the matter's point of view, but consciously through the mind of God. What Leibniz did was put consciousness in each particle of matter with no absolute space. Everything now emerged from the relations. It was a relativistic theory. Everything emerged from the interrelations of everything in the universe, which were, each one had mirrored the universe from its own point of view. So every particle was in a different place from everything else, therefore saw it from a different point of view. So that was a kind of panpsychist view of interconnectedness. And these very interesting ways of thinking go right back to the 17th century when the idea of gravity first came up. And actually, it's just as mysterious today.
Yeah, I mean, I've been thinking about this actually in relation to the notion of love, because it strikes me that when Dante, for example, about whom I've written, concludes the Divine Comedy, he ends it with this famous vision in which he feels himself to be spinning, he says, like a perfect wheel with the love that moves the sun and the other stars. So that feels a bit Leibnizian, actually, at least in this moment, that within himself, he knows himself to be part of a reflection of, or an echo or refraction of the love that is the dynamism that's moving everything else in the cosmos. And it's been making me think about how we might reimagine love, not just as a personal feeling, but as a sort of an objective fact. And the way that love's talked about, of course, as a love is talked about as a force of attraction, reaching across distance, and maybe more or less instantaneously as well. Whether there are links, and it's not just, I think, a linguistic possibility, because I also know that Newton, he was very influenced by the writings of Ficino, the Renaissance Neoplatonist, who was translating into Latin the works of Plato at the time. And the esoteric side of Newton was very fascinated by the ancient Greek notion of the daemons, which are these go-between entities. And in particular, Ficino wrote about Eros, that was the sort of chief demon of attraction, if you like. And I think this has been established by scholars now, that historians of science, that this vision of a cosmos filled with the influence of Eros, of love, very much inspired Newton's sense that there could be a cosmos filled with the influence of gravity, which he then was able to mathematize and so on. But that, in a way, you're saying perhaps that was sort of his private ruminations inspired by his more esoteric interests that later in life he talked about in terms of the will of God, and the notion that there's a kind of field of God's will perhaps isn't, so much different from the old Dantean notion that love is that which fills all things and brings them, the spirited notion of their dynamism spinning with the love that moves the sun and the other stars. It's very striking that, Dante's vision of God is not static. It is this very dynamic vision, in fact.
I suppose that the love, the idea of gravity as love, one thing that perhaps fits that is the fact that gravity is essentially unitive. What it does is ties all things together. And the universe has been expanding since the Big Bang, according to modern cosmology, because there's a force pushing it apart, which is now called dark energy. But if the dark energy wasn't doing that, or if there wasn't enough dark energy, the universe would slow down its expansion because of gravitational pull, and then everything would contract. And, all the equations show that it would be like the opposite of the Big Bang, the Big Crunch. Everything would collapse into an ultimate black hole. The gravity by itself would bring everything together. It brings things together. It doesn't separate things. It always brings them together. And what's more, and what's I think find really puzzling, and I've just been reading about Faraday and his ideas on force. He was utterly puzzled by gravity because you can't unify it with electromagnetism or other forces. All grand unified theories have tried to do it and failed. Einstein failed. And even today, quantum theory and relativity theory, which relativity is about gravity and quantum theory about the microscopic organization of matter, the two theories are incompatible, and they're the two most fundamental theories in physics. They haven't been unified. People are always trying. But the thing about gravitational force is that it's not diminished by being used. That, say, a meteor comes through, is going through the solar system, it's sort of traveling through free space, and then it's brought within the gravitational field of the Earth, and then it comes down and crashes into the Earth. There's a huge amount of energy in the meteor, kinetic energy. When it hits the Earth, it can create a big crater, and throw up lots of dust and smoke and stuff. There's a huge amount of energy involved, but the Earth's gravitational field loses no energy at all in causing that to happen. In fact, it gains gravitational mass because the meteor adds to the mass of the Earth, which now has a stronger gravitational pull. So, in a sense, the Earth is the gravitational field of the Earth is causing things to happen through forces which act at a distance, but or through the force field of gravitation, but it's not losing anything by doing it. So here we've got something which loses nothing by bringing things together, and its whole tendency is to bring things together. And if the dark energy wasn't pushing them apart, the whole universe would in fact collapse into one blob, which would then contract as far as it conceivably could under the force of its own gravity. So something that brings everything together and holds the entire universe together, prevents anything escaping from this togetherness of everything, is indeed like a kind of love principle writ large at the most cosmic possible level.
It's very, very fascinating. Look, this is a bit of a tangent perhaps, but when you talk about that gravity in that way, it makes me think of the old Aristotelian notion of God as the unmoved mover. And the point for Aristotle was that God is the sort of omnipresent attractor, if you like, which everything that's in the cosmos is seeded to desire and want. And the many different things in their different modes of existence are each in their particular way, ultimately, as a kind of final cause, as Aristotle put it, seeking, if one can use that metaphorically, seeking to fulfill that instinct, almost that impulse or habit that has been put into them by being part of this whole, wanting to find the fulfillment that the whole might bring. And I think this is very fascinating because I think what one of the things that happened when gravity was born is actually remembers in the word itself, that the word gravity, of course, had existed before Newton, and before other figures like Galileo were working on it. But it meant the tendency to have weight, in the sense of, particularly the two elements of water and earth were felt to be particularly open to gravity, whereas the elements of fire and air were thought to be more open to the notion of levity. And so levity was the tendency to move up, gravity was the tendency to move down. And these were just different aspects of this one desire to move towards the divine, to seek fulfillment. But both aspects were felt to be needed. And I think one of the things that sort of disturbed people when gravity was taking on its more modern sense and becoming conceived of as, well, a force in nature, even if that force was a mystery at the same time, for the reasons you were saying, was because it was felt that the two aspects were becoming separated. So, for example, when Galileo, for example, designed a freestanding clock, where you could see the complete mechanism of the clock, the pendulum, which of course is a way of drawing on the gravitational energy to turn the cogs of the clock. But they could see that it was only drawing on gravity, and there was no role for levity in that mechanism. And so clocks were sometimes seen as almost diabolical machines. And because they were sort of separating out one aspect of the divine economy for a particular use, and excluding another aspect, it's not quite the same set of forces, but the same, I think, thing disturbed people about windmills, because when windmills started to become much more a common feature, say, of the European landscape at the early period in the Renaissance, the beginnings of mercantilism, and windmills were seen as extracting one part of the pneumatic whole. We've talked about this before, but the word pneuma in the Greek means wind, breath, and spirit. And so when Plato talks about that side of life, he can talk about how the pneuma is taken in, becomes our pneuma, breath, and then that is part of our pneuma, spirit. There's a kind of holistic sense of movement there again. But what a windmill did was just extract the wind and, as it were, not be bothered about the breath and the spirit. And they were very practically useful, but nonetheless sort of disturbing as well, as if they were cutting up the cosmos, cutting up reality, and in particular dropping the part that might be seen as most closely relating to God. And purpose is linked here too, because in Aristotle's physics, gravity and levity are seen not just as abstract forces, but as tendencies, directions of travel for um, entities that live in the cosmos, that are in the universe. So they give sort of shape as well as having these practical uses. Now, look, that's a bit of a spin-off in a number of different directions, but is that partly why this understanding of gravity interests you? Because it does seem to link to more purposeful or meaningful ways of imagining physics and the cosmos, therefore.
Well, yes. I mean, I think gravity acts as a final cause. In other words, I think it's attracting from the future. Um, and certainly the attraction, it works by attraction. And attraction means being pulled towards a future state. So if I hold something up and I let it go and it falls down, being pulled towards its future on the floor, as it were. So that's one thing that it has a, and if the attractor of universal gravity were got its way, as I say, it would result in the entire universe being pulled together, a bit opposite the Big Bang. And the principle of levity in modern cosmology is really dark energy, because the Big Bang happens because things are thrown apart. There's an energy pushing them apart, and according to modern observations that the universe's expansion is accelerating rather than decelerating, means that they've had to invent ever increasing amounts of dark energy to explain the expansion of the universe. Now, so you have these two opposites, that if gravity took over, if that was the end of everything, everything would collapse into a black hole and end up in total darkness. And if levity or dark energy is dominant, the universe would expand more and more at an accelerating rate. And Roger Penrose has pointed out that if that happened, there'd come a point where matter itself evaporated into light, until you'd end up with universal light, infinitely extended or almost infinitely extended. So these two principles, we still have them, levity and gravity, in our cosmology, and they're in a kind of balance with each other.
Yeah, I mean, it's there is a sense of these older ideas returning in relation to new physics, and that these are tremendous new discoveries and speculations based upon modern physics. But it is interesting how those speculations bring back older ideas. Another source on this that I was just recently reading was the philosopher who's a great advocate of panpsychism here in the UK, Philip Goff. He's just got a book out called Why, the Purpose of the Universe. And in that, he talks about how if this panpsychist idea is part and parcel of what has heretofore been called the material world, then intentionality goes all the way down, quite as much as the dynamics of force go all the way down. And he is quite prepared to speculate that the universe, therefore, can be seen as having a purpose as a whole, which we play a part in. But in a sense, nothing is forgotten. And so, in particular, he feels this is a way of trying to understand the suffering of life. that it's all part of a great project of realization, that the universe learns from our experience. Everything is sort of absorbed and taken in. And although he doesn't use the word love in the book, I spoke to him as part of this research I was doing, and he did say, yeah, he feels that the universe is absorbed with the one task of bringing about the best possible states for everything that is within it. And whilst he doesn't think that the universe itself is conscious in a meta-conscious kind of way, knowing what it's doing, as it were, it's much more instinctual for him. Nonetheless, he felt that this could be called a supreme act of love, because in a way the universe can be imagined as giving itself to these best possible states for everything that is within it. Now, this is he's not religious in any traditional sense, but I think his reflections upon the physics, through his deep knowledge of all that, with philosophical spectacles on as well, it's very fascinating that it's leading him to bring back these kind of notions. And of course, he's working very hard to bring them into the mainstream and not just have them as fringe interests or even as taboo.
The old tradition, of course, is of the world soul, and in a sense, gravity takes on the role of the world soul. Plato and many other, and Plotinus and other philosophers thought that the whole universe has a soul, or is within a soul. And the soul held everything together. Well, that's what the gravitational field does. So I think this ties in with Goff, and I mean, there's a long tradition behind what he's saying. But I myself, one of the things I've got is perhaps this is too big a topic to introduce, or at least to discuss at length, because our time's nearly up. But looking at since I think the foundational basis of everything is Trinitarian, and the Holy Trinity is the Christian version of this, if one says, well, the one aspect of the Holy Trinity, God the Father, is the ground of being, is being, pure being itself, the conscious being. Well, what would be the reflection in the universe of God the Father? Well, I suppose gravity and matter, because matter is being, located being, and it's all interrelated, as we've been saying. I mean, so this would be like God the Father as the ground of everything. It's the gravitational field, according to Einstein, isn't in space-time, it is space-time. It's the actual container of everything that happens. And then if you take electromagnetism, which are the other great forces in nature, apart from the nuclear forces, but electricity and magnetism and their relationship are very similar to the principle of the spirit and the logos. The logos in the Holy Trinity is the principle of form, structure, order, pattern, relationship. And the magnetic fields are like that. They all have form. They're extended in space. They interact. They have attractive and repulsive properties because of the polarity and stuff. So there's an inherent polarity. They're spatial magnetic fields. Whereas electricity is, although there can be static electricity, is mostly about flow. And you have huge electric currents flowing through the arms of galaxies, magnetic field lines 1 million light years long, and so on, vast amounts of electricity in the whole universe. And electricity is like the spirit principle, it's about flow, and magnetism is like the logos principle, it's about form. And so in these three major forces of nature, the being itself, where energy is confined through circulating, rotating into matter, as David Bohm says, matter is frozen light. The energy of light, as soon as sort of energy turns around on itself, goes in an orbit, like electronic orbit, so is confined and becomes repetitive with repetitive cycles. Then you've got matter, located matter, and matter then has all this gravitational connection with everything else. And then light is that free-flowing principle of energy and spirit and electromagnetic radiation filling the entire universe. So we have, in the gravitational aspect of matter, a reflection of God the Father, and in electric currents and electric flow and light itself, a reflection of the Holy Spirit, and in magnetic fields and formative fields in general, a reflection of the Logos. So anyway, that's one of the ways I've been thinking about it.
Yeah, no, look, I like that notion because I feel that the impulse behind it is to sort of go with the flow of the the modern physics, the modern understanding, but sort of push it to see what lies within it and around it and underneath it. Rather than a religious response, which might be to feel defensive against the science or even rejecting it.
Hmm.
Because, at the end of the day, physics is a form of contemplation on the nature of reality. So why wouldn't these patterns reappear? And for all that physics is mostly mathematics, and that's a very sort of niche way of engaging with reality. Perhaps these deeper patterns are the way that they can make sense to us too. And so, can be in a kind of dialogue with the older traditions, revealing the pattern of things. So yeah, that's actually a very helpful notion, I think. Hey, look,
Well, we should take it up perhaps in a future conversation, and because I think the relation of electromagnetism to consciousness is, I think, something that's very deep and important. But we haven't time to discuss it now. So I think, but in what I conclude from all this really is that some of the most obvious things we know about, like gravity, that we live within it all the time, we take it completely for granted, are actually, the more you think about it, profoundly mysterious. And reading Van Flandern's paper on the speed of gravity, you realize just how mysterious this is and how little even physicists think about these problems, because they're just too mysterious, like koans, they're just too mysterious. So we just treat it in a kind of banal way. Here's an equation, just calculate.
yeah, no, it's worth remembering because we feel gravity all day, every day too, and so being able to get some sense of being immersed in the mystery of that
Yeah.
is very helpful. It's part of the re-enchantment of life. So look, thanks very much indeed.
Thank you, Mark.